Hi everyone, and welcome to lesson 21.2, part 1. We are going to divide this lesson into 2 different days, and we're going to start today on page 284, where we're going to talk about simplifying trigonometric expressions. So when we are looking to complete identities using trigonometric expressions, we kind of have a list of strategies to start solving them. Kind of like we did with algebra, you want to look at some different strategies that are special to these trig expressions. So sometimes substituting is helpful, and that goes back to using this list that you hopefully kind of started for yourself yesterday of the trig identities, reciprocal, and Pythagorean, and rewriting with cosine and sine for tangent and cotangent. You'll notice that that's something on there. Using multiplication or factoring, rewriting expressions in terms of sine and cosine, combining into a single expression, rewriting division as multiplication. And I also like to add in one last one that's breaking up. Sometimes we'll see an example of this too, breaking up division by a single term into separate pieces. Okay. Now, some of this may or may not make sense at the moment, what this list of strategies will do, but when in doubt, when we're starting these problems, look through this list and see if any of them can help you get started. Now, the book looks at a couple of different examples, and the first one is giving us the expression sine theta, cotangent theta, secant theta, and we want to simplify it as much as possible. Okay, so first, one of the strategies that they're implementing is rewriting everything in terms of sine and cosine. So we're taking that cotangent of theta and making it into cosine over sine, and then secant we're writing as the reciprocal function 1 over cosine. Now what can happen is things cancel out. The 2 cosines can cancel, one in the numerator, one in the denominator, because we're multiplying. And then the sines cancel, and we're actually just left with a simplified expression of 1. Another example is part B, example B here, where we have tangent squared theta minus secant squared theta plus 1. Well, the first thing they do is they take tangent squared plus 1. They reorder this because using our list of Pythagorean identities, tangent squared plus 1 equals secant squared, and then we end up with secant squared minus secant squared, or 0. Okay, so now we're going to try simplifying some on our own, and again, looking at that list of strategies will be helpful to us. Now, something you might notice in part A is that we are given right here the Pythagorean identity of cosine squared plus sine squared. Now, normally write sine squared plus cosine squared. Again, you can reverse that order, and it equals 1. Because again, addition is commutative. So end up with 1 minus 1 when we substitute in. Well, 1 minus 1 is 0. For example B, this is very similar to example A up above, that a strategy we might want to employ is writing everything in terms of cosine and sine and seeing what can possibly cancel out. Okay. Now, something we're going to see here is if we start writing this, we have cosine theta, and then cosecant theta can be rewritten as 1 over sine. And then we still have that cotangent theta in the denominator. Now, again, we probably want to rewrite this cotangent theta as in terms of sine and cosine. But something that might be more helpful to start here is rewriting cotangent in the numerator using the reciprocal identity, because what this will allow us to do is not have a fraction within a fraction in our denominator. So tangent can be rewritten as sine over cosine. So we still have cosine theta times 1 over sine theta. And now tangent is rewritten as sine over cosine. And then now we can see that some things are going to cancel out. The sine in the numerator and the denominator, the cosine in the numerator and the denominator. So we are just left with 1. Last but not least, we have 1 minus sine squared. And 1 minus sine squared is a variation of our original Pythagorean identity, sine squared plus cosine squared equals 1, because we could subtract sine squared over and replace 1 minus sine squared with cosine squared. So we end up with secant of theta and then times cosine squared. And then 1 over cosine theta times the cosine squared. If we write it as a reciprocal, and we see that one of the squareds in the numerator can cancel with that cosine in the denominator, and we're just left with 1 times cosine, which is cosine. So that is as simplified as that expression will get. Now, we don't always have to simplify trig expressions the same way. These examples, I would kind of say that would probably possibly be the quickest route, but you will see, especially the more complex the trig expressions are, they may or may not be able to be simplified the same way. So keep that in mind as we go through these. Okay? Now we're going to skip number 1 and jump down to number 2 on page 285, where they're giving us another example to kind of look through here. Now notice in this original expression, we have sine squared minus cosine squared. Sine squared minus cosine squared is not the same thing as sine squared plus cosine squared. Okay, that's very different, that being an addition sign versus a subtraction sign. What we can do, however, if you look in the math tip box, is use a difference of 2 squares. Going back to our original strategies, factoring, including a difference of 2 squares, may be helpful. So we can factor this to be sine squared minus cosine squared to be sine minus cosine and sine plus cosine. And again, difference of 2 squares is reviewed over to the right here. Now we can cancel these expressions with each other, and as simplified as this will get is just sine minus cosine. Example 3 looks at this as well. Another example here. The original expression is tan plus 1 over tan. Now, this is where getting a least common denominator is helpful, because to be able to add these together, notice this isn't multiplication, we can't just cancel, we need a common denominator. So we're going to multiply tangent of theta by tangent on the top and the bottom to get that common denominator of tangent theta. And then we can combine these so that they have that least common denominator, tangent squared plus 1. Which we can rewrite as secant squared. Secant squared can be rewritten as 1 over cosine squared using the reciprocal identity, and tangent can be rewritten as sine over cosine. These multiplying by the reciprocal will allow us to get cosine over sine. Cosines will cancel, and we are left with just 1 cosine times sine in the denominator, which can be rewritten with the reciprocal identities as being cosecant secant. Okay, so there's another example on what we are doing there. Okay, one final group of examples before we end the lesson for today is example 4 with 4 more examples. Okay. And looking at example 4, a couple of things here. What we notice, a good strategy again to employ is rewriting things in terms of cosine and sine for 4a. Because cosecant of theta can be rewritten as 1 over sine theta, right? So we already have 1 over sine theta. Now we also have another. So because these two have a common denominator, we can rewrite them as one singular expression with that common denominator of sine theta. So 1 plus 1 is now 2. And then we have this cosine theta out front. So when we combine this, distribute that cosine in, we end up with 2 cosine theta. Oops, let me write that a little nicer. 2 cosine theta over sine theta. And then cosine over sine can be rewritten as cotangent of theta. So we can have it in one singular expression, since those can be rewritten. The next example looks at cosecant theta minus tan theta times cosine theta. And again, a nice strategy to try to see if we can work some things together is rewriting cosecant as 1 over sine and then rewriting tangent in terms of cosine and sine, and seeing if anything simplifies. So on the right-hand side, the second term here, what we're going to notice is these cosines can cancel out, and we're left with this 1 minus sine, or 1 over sine minus sine. Now, currently, we can't combine these two anymore because they don't have a common denominator. What we can do is get a common denominator, though. So we have 1 over sine, and we have minus sine. So a common denominator here would be changing this piece so that it does have a denominator of sine. And to do that, we would have to multiply the top and the bottom by sine. Now we have this least common denominator of sine theta, and our numerator will be 1 minus sine squared theta, which, if you look at your formula sheet, should kind of trigger again with the Pythagorean identity, that 1 minus sine squared can be rewritten as cosine squared. And then realistically, there's a couple ways you can go, but probably this could be a potential answer. Another way you might see this rewritten is if you break this into just being cosine theta times cosine theta divided by sine. To rewrite this as one not fraction, cosine over sine can now become cotangent times cosine. So this one doesn't simplify to be very pretty, but this is probably the best answer to see it as just a numerator expression. Last example for today is part C, and we have sine theta minus cosecant theta over cotangent theta. So again, to start, let's look at this as rewritten in terms of cosine and sine, okay? Actually, let's not look at it that way. This is going to get a little complicated if we do that. And again, there's more than one way to do this, but one thing I wanted to say with this is going back to that list of ways. I brought up this break up the division into a single term, right? So notice we're only dividing in this problem by cotangent. And this is a good example of where sometimes dividing it into two separate fractions instead of making it into one with the least common denominator might be helpful, okay? Because what we can do here is if we simplify each of these like they are their own problem, we can rewrite this as sine times tangent, using the reciprocal identity, minus cosecant theta times tangent. And now if we rewrite everything in terms of sine and cosine, so the tangent gets rewritten as sine over cosine, secant's 1 over sine, and cotangent sine over cosine. What we will see is that some things are going to cancel, like the sines. And again, we now have sine squared over cosine on the left, minus 1 over cosine on the right. They have a least common denominator, so now is a good time to probably put them back together since they both have a least common denominator of cosine theta. So that's our new denominator. And then sine squared of theta minus 1, again, is not a Pythagorean identity. 1 minus sine squared is cosine squared, right? But sine squared minus 1 is not necessarily an answer here. What we could say it is, though, is if we subtracted 1, so we had sine squared minus 1, we'd have to move the cosine over on this one so that it equaled negative cosine squared when you rearranged. And finally, these would cancel, and you're left with negative cosine of theta. So a couple of tips with this. Again, really helpful if you have a list in front of you to always kind of be checking and seeing if things should be rewritten. Again, there isn't always just one specific way to solve these. All right, it's almost like a puzzle. There's no one way. This one, again, we could have started a different way. I just wanted to show you how breaking it up could be useful. But there might have been another way you solved this in order to find the same answer. Okay, so be aware that this is going to take a lot of practice, and the more you try it, the more you see these examples, the easier these will get. Okay, and we will work with some examples in class, and we will look at then part 2 in the next lesson. Thanks, everyone.